Hello everybody, it's Goknath from the Crack with Gokulnath YouTube channel. So guys, today we're going to solve some of our JEE mains questions. So let's be start to solve guys. The first question is the quadratic equations x square minus 6x plus a is equal to 0 and x square minus 3x plus 6 is equal to 0 have one common root. The other roots of first and second equations are integers in the ratio of 4:3. Then the common root is what? So guys, this is the question. So first I will write these two equations here. So the equations given in the question are x square minus 6x plus a is equal to 0 and x square minus cx plus 6 is equal to 0. These are all the equations given in the question. Now let me take the common root of both the equations as alpha. That is what I am taking, because in the question they are saying both the equations as one common root, and that is why I am taking the common root of both the equations. I am taking it as alpha. That is what I am assuming now, because they are saying both the equations as one common root. Read the question carefully. So as one of the roots is common root, so I am writing that common root as alpha. So what will be the other roots? The other roots will be nothing but 4 beta for the first equation and 3 beta for the second equation. 4 beta for the first equation and 3 beta for the second equation. Why? That's because in the question they are saying the other roots of first and second equations are in the ratio of 4:3. So what is the ratio of 4 beta is to 3 beta? That is 4:3. In order to fulfill the criteria given in the question, I am assuming the roots as this value, which is 4 beta and 3 beta. So 4 beta and 3 beta I am taking it as roots of other roots, because in order to fulfill the criteria given in the question, which is 4:3 ratio, the other roots of the first and second equation should be 4:3. So here it is 4:3 only, right? Because 4 beta 3 beta is 4:3. So in order to do that only I am taking like that, and don't think that your beta has a root. Your 4 beta is only the root and 3 beta is only the root of second equation. 4 beta is the root of first equation, 3 beta is the root of second equation, and not at all beta. Because of the ratio only I am writing it as 4 beta and 3 beta. I know you guys will think alpha and beta is the root. No, your alpha and 4 beta is only the root, and for second equation your alpha and 3 beta is only the root. Don't think like that. That is why I am saying to ensure you people and make a warning for you. Make a precautionary measures. Okay? That is what I did. So these are all the roots. Now what I am going to do is listen carefully. For the first equation I am going to find the product of the roots. Product of the roots means alpha into 4 beta. Alpha into 4 beta is 4 alpha beta. Just I found the product of the roots. So alpha into 4 beta will be 4 alpha beta. Product of the roots is nothing but your C by A. Sum of the roots is minus B by A. Product of the roots is C by A. So C by A will be A itself, because C in place of C we are having A. That's why your 4 alpha beta, which is product of the roots of first equation, is A. And for the second equation also find the product of the roots. For second equation, product of the roots is alpha into 3 beta, which will be nothing but 3 alpha beta. Because alpha into 3 beta is 3 alpha beta. So that is also C by A, which is 6. Because 6 divided by 1 will be 6, and that's why your product of the roots for second equation is also 6. So 4 alpha beta is A, 3 alpha beta is equal to 6. Now if 3 alpha beta is equal to 6, I would say that your alpha beta will be 2. Very simple thing. If your 3 alpha beta is equal to 6, and alpha beta will be 6 by 3, which will be 2. That's a basic relation. So alpha beta will be 2 just by using this relationship. Now if alpha beta is equal to 2, I would say that your A will be nothing but 8, right? Your A will be nothing but 8. If and only if your alpha beta is 2. I know the alpha beta value which is 2, and then I would say that your A is 8 just by using this relationship which is 4 alpha beta is equal to A. We know your alpha beta is equal to 2. If alpha beta is equal to 2, then A will be nothing but 4 into 2, which will be 8, and that's why I am saying your A is 8, correct now? And that's why I am saying your A is 8. So now we know the value of A as 8 just by using this relationship which is 4 alpha beta is equal to A and putting alpha beta as 2. That's all. Now if I know the value of A as 8, what can I do now? What can I do now? What can I do now is, listen carefully. Now I can put the value of A as 8 in the first equation, because in the first equation only I am having the A in it, correct now? So if you know the value of A which is 8, so I would put the value of A as 8 in the first equation. So we are having A at the constant value, so I will take out the A and I will replace it as 8, because we know A is equal to 8, and that's why I'm putting A as 8 in this first equation, which is x square minus 6x plus A. When I put 8, you will get x square minus 6x plus 8 is equal to 0. That's what I did now. Now guys, now I will rub this. This is what I did. The next step which I am going to do is, listen carefully guys, try to find out the roots of this equation. Try to find out the roots of this equation either by your roots formula or your factorization method. Any method which looks easier for you, do it. So using a roots formula or a factorization method, find out the roots. When you find out, you will get the roots as 4 and 2. 4 and 2 will be the roots for this equation. Okay, just find out. Just use your rough note and do it, and you will get the roots as 4 and 2. So the roots of this equation will be nothing but 4 and 2. Just by your factorization or otherwise your what? Roots formula. So 4 and 2 will be the roots of this equation, which is first equation for the first equation. If 4 is 2 is the roots of this equation, now try to understand either 4 or 2 will be the common root, right? Either 4 or 2 will be the common root, but they are asking the value of the common root. Either 4 or 2 will be the common root, but which one will be the common root? But which one will be the common root? How would you choose that? How would you choose that? That is by the clue given in the question. In the question they are saying the other roots of first and second equations are in integers. If they are in integers, that's a clue which they are given in the question. So either 4 or 2 will be the common root. That everybody know. So now please understand, they are given a clue as other roots of first and second equations are integers. That's a clue for us. So first let me take the common root as 4 guys. Let me take the common root which is alpha as 4. Because your alpha is only the common root, right? When I take your alpha as 4, then I will get your beta as what? Then I will get your beta as 1 by 2, correct now? If I put your alpha which is common root as 4, you will get the beta as 1 by 2 just by this relationship which is alpha beta is equal to. If alpha beta is equal to, if you put alpha as 4, you will get 4 beta is equal to. 4 beta is equal to 2 means then your beta will be nothing but 1 by 2. That means 2 by 4 will be 1 by 2. I am just saying by this relationship. Because if alpha is equal to 4, then your beta will be 1 by 2. Then only the product will be 2. I hope that makes you clear. So if beta is equal to 1 by 2, what will be 3 beta? What will be 3 beta? That will be 3 by 2. Because beta is equal to 1 by 2 means then 3 beta will be 3 by 2. And we know that your 3 beta is another root of second equation. Correct na? For second equation only 3 beta is another root. I told right? For the first equation, another root is 4 beta. But for the second equation, another root is 3 beta. And this 3 beta, which is another root of second equation, is not at all an integer. Is not at all an integer. If it is not at all an integer, that shows that I am not correct. I am not at all at the right path. So, this 3 beta, which is So this is the second other root of second equation, which is 3 beta, is 3 by 2, which is not at all an integer. If it not at all an integer, then I would say that your common root is not 4. Your common root is not 4. So this is wrong. This is wrong. Okay, guys, please understand. This is wrong because your another root of second equation is not an integer when you put alpha as 4. When you put alpha as 4, which is common root as 4, you are not getting the other root of second equation as an integer, and that's why this is wrong. Now let me take, now I will cancel out this 4 because 4 is not a common root. Let me take the common root alpha as 2, which is common root as 2. When you take alpha as 2, then you will get your beta as nothing but your 1 by 2, correct na? Not 1 by 2, 1, okay? Because guys, alpha beta is equal to, if alpha is equal to, then beta will be nothing but 1, just by this relationship. Because alpha is equal to means, then beta will be nothing but 2 by 2, which is 1 by the 20 I am saying. Then what will be your 3 beta? 3 beta will be 3, and now I am getting an integer. And now I am getting an integer. That means your alpha is equal to 2. Your alpha is equal to 2. It's a very good question, guys. We know that alpha is equal to 2, which is common to 2, means the beta will be 1. If beta is 1, 3 beta will be 3. And 3 beta is the second root of other root of second equation. And the other root of second equation should be integer. And of course, when you put alpha as 2, you are getting the second root as integer. So I am getting 3 beta as 3. If I am getting second root of both the first and second equations integer, that means I am correct. And that's why I am saying your alpha is equal to 2, and that is a correct statement. So your common root is nothing but 2, guys, and that's the answer. So just I am eliminating. It's not a very big deal. It's not a very big deal. Just your elimination process or splitting down. And that's how I found. Because guys, you guys may ask why only I am finding for 3 beta. Because 4 beta is also another root. 4 beta means it will be 4 only. Anyway, you are getting integer. No problem in that. So that's why I am saying directly I am just checking with 3 beta. You are getting 3 beta as 3, which is an integer. And that's why this relation is correct, which is alpha is equal to. If your alpha is equal to, then definitely your common root is 2, because your alpha is only the common root. So that's all, guys. Your answer is equal to 2. So that's all about this question. Let us move on to our next question. Our next question is cosecant of root 5 plus cosecant inverse of root 65 plus cosecant inverse of root 325, and it's going on up to infinity. And they're asking us to find the value of sum of this infinite series. So guys, the first step which I'm going to do is I'm going to convert every trigonometric ratios in terms of tan inverse. That's the first step which I'm going to do. So how I would convert every trigonometric ratios into tan inverse? That's by your triangular method. I'm going to use our triangular method not to convert all these ratios in terms of tan inverse. So guys, first let me show you a demo on how to convert. We are having cosecant of root 5, right? So how I would convert is, let me draw a right angled triangle. This is a right angle triangle I draw. Now cosecant of root 5 we are having. What is cosecant of root 5? Cosecant of root 5 means your cosecant theta is equal to root 5. If your cosecant theta is equal to root 5, what is cosecant theta? That is hypotenuse to be opposite because the reciprocal of sin theta. Because the reciprocal of sin theta, your cosecant theta is hypotenuse to be opposite. As we know, cosecant theta is equal to root 5. Your hypotenuse will be root 5. And opposite will be 1 because it is a hypotenuse should be opposite as it is a reciprocal of sin theta. So hypotenuse should be opposite will be root 5 divided by 1. So root 5 1 I wrote. Now what will be the adjacent? Find out the adjacent using a Pythagoras theorem. Adjacent will be nothing but root 5 whole square minus 1 square, which will be nothing but 4. So root 4 will be nothing but 2, and your adjacent is equal to 2. Using a Pythagoras theorem, I have found the value of adjacent is 2. Your value of adjacent is 2. What will be the value of tan theta? Your tan theta will be nothing but opposite divided by adjacent. Opposite divided by adjacent is 1 by 2. So your tan theta is equal to 1 by 2. So I would write this particular ratio as tan of 1 by 2. Tan inverse of 1 by 2 just by the triangular method. Just by the triangular method. So this is how we should use the triangular method, and that's how we should convert all these trigonometric ratios into tan inverse. Same like that do here also, guys. For every ratio I can't do because then it will take more time of you. That's why I'm to showed you a demo. You should do for other terms. So just do it and you will get for other terms as tan inverse of 1 by 8 plus tan inverse of 1 by 18. Okay, I'm just using triangular method only. I'm saying you will be getting tans of 1 by 8 plus tans of 1 by 18. Just converting these ratios into terms of tan inverse, and it will be going on up to infinity. Sorry, not 8, infinity. Okay, so infinity, it will be going on up to infinity. Now guys, what I'm going to do is I'm going to find the general term of the series, that which we mean by nth term, right? So I'm going to find a general term which we nowadays we mostly all call as nth term. Yes, that's correct. So general term or nth term, that is what I'm going to find now. So observe the series carefully and find out the general term. So when you observe, the general term will be nothing but tan inverse of 1, because guys, in every term I am having 1 in the numerator. That means then of course 1 should be there in your general term of the numerator. So 1 divided by 2n square. So how would I know that this is the general term? Very simple thing. First put 1 in place of n. When you put 1 in place of n, you will get tans of 1 by 2. When you put 2 in place of n, you will get tans of 1 by 8. When you put 3 in place of n, you will get tans of 1 by 18, and it's going on up to infinity. Just put those values and you will be correctly, every value will be matching. If they are matching, that means this general term which I choose is a correct one. Okay guys, so tans of 1 by 2n square is the general term. So I will write this is the general term. Now I know the value of general term, and they are asking us to find the sum of this infinite series. Now if I know the general term and they are asking us to find the sum of this infinite series, what would be the next step which I am going to do? The next step which I am going to do is I am going to put summation of your general term. Summation of your general term will be giving as, that means the sigma notation or summation of a general term will be giving as sum of this infinite series. Correct now? Correct now? So summation of or your sigma notation of this general term will be giving as sum of this infinite series. So I will put the summation. So summation of tan inverse of 1 by 2n square from n is equal to 1 to infinity. Because guys, this is an infinite series. If it is an infinite series, then this would be nothing but summation of tans of 1 by 2n square from n is equal to 1 to infinity, just like a standard form. You can take it as a standard form itself. So tans of 1 by 2n square from n is equal to 1 to infinity, because this is an infinite series. Now your manipulation part starts. Now this is the point where your manipulation part starts. So what I am going to do, listen carefully, I am going to multiply 2 on both numerator and denominator. When you multiply 2 on both numerator and denominator, what you will get is, you will get it as 2 by 4n square. Because already I am having 1 by 2n square. When you multiply 2 on both numerator and denominator, you are getting as 2 by 4n square, and that's what I am getting now. Now what I am going to do is, listen carefully guys, summation of n is equal to 1 to infinity of tan inverse of 1 minute of tan inverse of 2 by 4n square. So guys, the denominator I'm going to add 1 and subtract 1. Denominator I'm going to add 1 and subtract 1. That's the part which I am doing now. So the denominator, just I added 1 and subtracted 1 so that this particular expression, which is 4n square minus 1, looks like a form of a square minus b square, right? If I add 1 and subtract 1, this particular expression, which is 4n square minus 1, looks like a form of a square minus b square, which is 2n whole square minus 1 square. What is 2n whole square minus 1 square? That is 2n plus 1 into 2n minus 1, just by your a square minus b square identity. A square minus b square identity is a plus b into a minus b. So this expression, which is 2n whole square minus 1 square, can be written as 2n plus 1 into 2n minus 1. And that is what I am going to write now. 2n minus 1. So just I added 1 first, then subtracted 1 in the denominator. Then I add a form like 4n square minus 1. 4n square minus 1 is 2n whole square minus 1 square. 2n whole square minus 1 square is 2n plus 1 into 2n minus 1, just by your a square minus b square identity. Correct now? That's what I am saying. So 2n plus 1 and 2n minus 1 will be nothing but 4n square minus 1. Just I am replacing using your identity. Now guys, now comes a very important part. Because guys, these things and all will not just come by solving one question, okay? Don't have this type of mindset. These type of manipulation thinking skills and all will not come just by solving this question, okay? It will be coming when you have solved variety of questions with this same type. So the next part which I am going to do is, in the numerator I am having 2, right? Can't I write this 2 as 2n plus 1 minus of 2n minus 1. Anyway, I can write like that now. This 2 in the numerator can be written as 2n plus 1 minus of 2n minus 1. Anyway, will be getting 2 because 2n minus 2 will get cancelled. And 1 minus of minus 1 will be 1 plus 1, which is 2. So I am getting 2. But what is the reason behind writing this 2 as 2n plus 1 minus of 2n minus 1? And what is the reason behind writing the denominator is 1 plus 2n plus 1 into 2n minus 1? That is the use your inverse trigonometric formula, which is tan of a minus tan of b formula, which is tan of a minus b. It will be 1 plus ab. For that only, so much manipulation I did, okay? For that only, so much manipulation I did. So I'll rub this, guys. Now you don't need this. So now this looks like a form of tan inverse of a, which is 2n plus 1 minus b, which is 2n minus 1, by 1 plus ab, which is 2n plus 1 into 2n minus 1. Does it look like a form? Yes, if it looks like a form, I can write it as summation of n is equal to 1 to infinity of tan inverse of a, which is 2n plus 1 minus tan of b, which is 2n minus 1. That is what I did now. So this looks like a form of tan of a minus b to 1 plus ab. So this can be written as tan of a, which is 2n plus 1 minus tan of b, which is 2n minus 1. So that's by using the formula of tan of a minus tan of b, which is tan of a minus b divided by 1 plus ab. That's how I am converting it. So this form of big expression converted into this form using that formula, which is tan of a minus tan of b, and that is the reason we can doing all such manipulation. Now I am arrived at this form of summation. Now I don't need this expression, so I rub this. Now what I will do now? Guys, very simple. Just expand this and find out the value. So what you need to do is, how would you expand this? First put 1 in place of n, next put 2 in place of n, next put 3 in place of n, and all the way up to infinity. Just by doing like that, you will be getting the answer for this, the value for this. So guys, when you put 1 in place of n, 2 in place of n, when you expand this, you will be getting many values. You will be getting many values up to infinity. But what you need to do is, there most of the values will be getting cancelled with each other. Most of the values will be getting cancelled with each other, and you will be left out with two terms. Which is nothing but these are all the two terms which you guys will be left out when you cancel much greater value, much values. So these two terms will be left out. So guys, what I am saying is, when you simplify, that means expand the summation, you get many values, and out of that most of the values will be getting cancelled, and you will be left out with two values, which is tans of infinity and minus of tans of 1. These two values only will be left out after cancelling out those values. So these two values will be getting cancelled. These two values only will be getting remained. So what is tans of infinity? That is pi by 2. What is tans of 1? That is pi by 4. So pi by 2 minus pi by 4 will be pi by 4. And that's the answer. And guys, I know some people already will tell the answer is pi by 4. Because guys, most of the question which looks like this form, the answer is pi by 4 only. I don't know why it is, but the answer is pi by 4 only. So guys, most of the question will look like this form, like cosecant inverse, tan inverse summation. The answer is pi by 4. In that way also many people say, but don't do like that in exam. Solve this in this procedure so that it will be good for you. So the answer is pi by 4 guys, because tans of infinity and tans of 1 is pi by 4. So that's all about this question. So let us move on to our next question. Our next question is, if x plus 1 by x is equal to 2 cos theta, then x to the power of n plus 1 by x to the power of n is equal to what? So guys, this is the question. So we are having x plus 1 by x is equal to 2 cos theta, right? So I can write it as x square plus 1 divided by x is equal to 2 cos theta just by taking LCM in the LHS. These are all the basic things now. Just I can write this as x square plus 1 divided by x is equal to 2 cos theta. Just a basic thing. Just I'm solving this LHS using your LCM method. That's all I did. Now this can be written as x square plus 1 is equal to 2 cos theta into x. When you cross multiply, correct na? When you take x to the RHS, you will just multiply. So x square plus 1 will be nothing but 2 cos theta into x just by cross multiplying. These are all the basic things, not a very such higher order, higher level mathematics and all. Basic. So this would be nothing but 2 cos theta into x when you take x to the right hand side. That's what I did. Now after this, what I am going to do is, I am going to take all the terms to one side. I'm going to take all the terms to one side in order to convert into a quadratic form of ax square plus bx plus c is equal to 0. I'm going to take all the terms to one side. One side means LHS. When I take all the terms to one side, it looks like a form of quadratic equation, which is ax square plus bx plus c is equal to 0. So when I take like that, this would be nothing but x square minus 2 cos theta x plus 1 is equal to 0. This is what you will be getting when you take this 2 cos theta x to the left hand side. When you take 2 cos theta x to the LHS, is left hand side, you will get x square minus 2 cos theta x plus 1 is equal to 0. This is a perfect quadratic form. which I wrote now. Now, listen carefully guys. Listen carefully. Now I am going to find the roots of this equation, and that is why I converted into a quadratic form. Okay. Now I am going to find the roots of this equation. That means the value of x that this equation can take. So what will be the roots of this equation? The roots of this equation nothing but your x. Because guys, the value of x is only root. You guys know that, right? The value of x that this equation can take is only your root. That is why I am writing it as x is equal to, using a roots formula, which is minus b. Minus b is what? Minus of minus 2 cos theta, which will be 2 cos theta. Then plus or minus root of b square minus 4ac, which is nothing but 4 cos square theta minus 4ac will be nothing but 1. Correct na guys? Then divided by 1 minute. Then what happened guys? Okay. Then divided by 2a. 2a will be nothing but 2 into 1, 2. Guys, just I'm using your roots formula, which is minus b plus or minus root of b square minus 4ac divided by 2a. So minus b is 2 cos theta plus or minus of root of b square minus 4ac with discriminant is 4 cos theta minus 1 divided by 2a will be 2 into 1, which will be 2 in the denominator. Now listen carefully guys. Guys, here it will not be 1, okay? 4. Sorry, I wrote it as 1, it will be 4. So for root of 4 cos theta minus 4, this will be your discriminant value. Now listen carefully. The discriminant, I will take your 4 common. I will take your 4 common. The discriminant, just I am taking your 4 common. So 4 into cos square theta minus 1. Now guys, now very simple thing. As we know 4 is 2 square. So I will take out of the roots itself. So 4 is your 2 square. That's why I will take out of the root. So when you take out of the root, this is what you will get, which is 2 cos theta plus or minus 2 into root of cos square theta minus 1 divided by 2, because of taking your 4 common, because 4 is your 2 square, right? 4 is 2 square. So I took 2 outside the root. So this will be your value, and just evaluate. Then you will get the value of x as cos theta plus or minus root of cos square theta minus 1. Because guys, just divide using a division of algebraic expression. 2 cos theta divided by 2 will be cos theta. 2 root cos square theta minus 1 divided by 2 will be root of cos square theta minus 1. Or use your factorization method. Factorize your numerator by taking 2 common, then cancel out. Then you will be getting cos theta plus or minus root of cos square theta minus 1. And this cos square theta minus 1 can be written as minus of sin square theta. Correct now? I can write like that now. Cos square theta minus 1 is the root of, minus of sin square theta. Because guys, I am using your Pythagoras identity. So Pythagoras identity tells that sin square theta plus cos square theta is equal to 1. If sin square theta plus cos square theta is equal to 1, then I would say that 1 minus cos square theta will be sin square theta. If 1 minus cos square theta is equal to sin square theta, then cos square theta minus 1 will be minus of sin square theta. Just the negative of the statement. Because 1 minus cos square theta is equal to sin square theta, then cos square theta minus 1 will be minus of sin square theta, just negative of statement, and that is why cos square theta minus 1 is minus of sin square theta, and this root of minus of sin square theta can be written as iota of sin theta. Iota of sin theta, and that is what I arrived. Because guys, root of minus sin square theta is nothing but root of minus 1. Root of minus 1 is iota, as you guys know. Root of minus 1 is iota. Root of sin square theta is sin theta, and that is what I wrote now. Very simple thing. Root of minus sin square theta is iota sin theta. We will root minus 1 iota, root sin square theta sin theta. That's all. Very simple. Now I found the value of x, which is cos theta plus or minus iota sin theta, and that is why I use such a quadratic formulas and roots formulas, and I arrived at this form of value of x, which is x is equal to cos theta plus or minus of iota sin theta, and this is your value of x, that means the roots of this equation. Now, if this is x, they are asking x to the power of n plus 1 by x to the power of n. If this is x, means what will be x to the power of n? Now guys, now comes very important part. This is x. We need to find the value of x to the power of n. How would you find that? One property should come into your mind. Here we are having cos theta plus or minus iota sin theta whole to the power of n. Whole to the power of n only is x to the power of n. So cos theta plus or minus iota sin theta whole to the power of n will be nothing but De Moivre's theorem. Guys, do you guys forget that? De Moivre's theorem only I am going to use now, because I need to do it right. Because cos theta plus or minus iota sin theta whole to the power n, that is what I need to do. So here in this situation, as soon as you see this, the first thing which need to strike into your mind is your De Moivre's theorem. Because guys, De Moivre's theorem only have this form of expression, which is cos theta plus or minus iota sin theta whole to the power of n, cos theta plus iota sin theta whole to the power of minus n. Using your De Moivre's theorem only, I am going to solve this. What your De Moivre's theorem say? It say multiply your power, which is n, with the theta's value. Just multiply n with your theta's value. So when you multiply n with theta's value, what you will get? Cos of n theta. Then plus or minus of iota of sine of, when you multiply n theta's value, you will get n theta again here. This is what our De Moivre's theorem says, right? When you need to power up to n, whole to the power of n means, then you have to write it as just multiply n with theta's value. That's all you need to do. So cos of n theta plus minus of iota sine of n theta. That's all you are needed to know. Now we have found the value of x to the power of n, which is cos of n theta plus iota sine of n theta, just by your De Moivre's theorem, which you learned in a complex number. So by multiplying n with theta's value. Now they are asking 1 by x to the power of n. 1 by x to the power of n is x to the power of minus n. So x to the power of minus is nothing but iota of sin theta whole to the power minus n, because we are having x to the power of minus n, right? So this is also very simple, same guys. So just multiply minus n with the theta's value, because your power is minus n, not n. Your power is minus n because it is 1 by x to the power of n. 1 by x to the power of n is x to the power of minus n. That's why I wrote that. So cos theta plus or minus iota sin theta to the power of minus n will be nothing but just multiply minus n to the theta's value. That is what your De Moivre's theorem say. So when minus n, when you multiply minus n with theta's value, what you will get? You will get cos of minus n theta. Cos of minus n theta is cos n theta. Is cos n theta. Because guys, cos of minus theta is always cos theta if you assume theta as an acute angle. That's a basic formula which you guys learned in your trigonometry. So cos of minus n theta will be cos n theta only. Then iota of sine of minus n theta, iota sine of minus n theta will be minus of iota sin theta, because sine of minus theta is always minus sin theta when you assume theta as an acute angle. So iota sine of minus n theta will be minus of iota sin n theta. So it is minus, that is why I should write it as minus or plus. So 1 iota n theta. Because guys, it is minus. That's why I am just reverse that symbol. Just I made it ulta. So I am having plus or minus in the x to the power of n, but here it will be minus or plus, because I am having iota sine of minus n theta. Iota sine of minus n theta is minus of iota sine n theta. Minus of iota sine theta if I am having means I should ulta the symbol. That means the reverse the symbol. This would be nothing but minus or plus. That's the basic properties of symbols. These and all you guys should know. So this is x to the power of n, this is x to the power of minus n, and I need to club them. If I need to club them, if I need to add them, then your iota sine of minus n theta and minus or plus iota sin n theta will get cancelled. Because guys, plus or minus iota sin n theta minus or plus iota sin n theta, because I'm having minus first. That's why both these terms will get cancelled, and cos n theta plus cos n theta will be nothing but 2 cos n theta. And that's the answer for this question. And it's a brilliant question. It's a brilliant question. So, and that's the answer for this question, which is x to the power of n plus 1 by x to the power of n is 2 cos n theta, because these two terms will cancel, and cos n theta plus cos n theta is 2 cos n theta. And it's a good question, guys. So, that's all. Because it uses various forms of thing, one of the main thing is de Moivre's theorem. De Moivre's theorem is very important. Just multiply your powers value with theta. Just multiply your powers value with theta, and that is the only method, that is the only way by which you can solve using your de Moivre's theorem. So that's all about this question. Your answer is 2 cos n theta. So let us move on to our next question. Our next question is integral of dx to be x into x to the power of n plus 1 is equal to a ln of x to the power of n plus 1 to be x to the power of n plus some constant c. And they're asking what is the value of a. So guys, in order to answer this question, first let me solve this indefinite integral. So what I'm going to do is, listen carefully, the denominator we are having x to the power of n plus 1, right? In this expression, in this particular expression, I'm going to take x to the power of n common. When you take x to the power of n common, what you will get? You will get it as integral of dx by x into x to the power of n, because I am taking x to the power of n common. Then you will get it as 1 plus 1 by x to the power of n. This is something you will be getting when you take x to the power of n common in this expression, which is x to the power of n plus 1. So x to the power of n into 1 plus 1 by x to the power of n. This is the remaining term which you will be having when you take x to the power of n common. Now what is this x into x to the power of n? That is nothing but x to the power of n plus 1. Your laws of exponents. Your laws of exponents. So this can be written as x to the power of n plus 1, because x into x to the power of n is nothing but x to the power of n plus 1. That's by your laws of exponents. That's a basic thing. Now listen carefully, guys. Now I'm going to do a substitution. Substitution which you guys are more familiar with. So I'm going to take 1 plus 1 by x to the power of n as some t. This is what the substitution which I was telling. I'm just taking 1 plus 1 by x to the power of n as t. If 1 plus 1 by x to the power of n is equal to t means, then what will be your dt? Your dt will be nothing but the differentiation of this, which is nothing but minus n divided by x to the power of n plus 1 of dx will be nothing but your dt, right? Correct now? If 1 plus 1 by x to the power of n is equal to t, means that dt will be nothing but the differentiation of this, which is minus n divided by x to the power of n plus 1. Not only that, then dx should be multiplied. So this will be your dt, because dt is a differentiation of this. That is why this is your dt. Now I know the value of substituted t, which is this expression, and the dt's value, which is this expression. Now let us substitute this value of t in this integral. So listen carefully, guys. When you substitute, what you will get, guys? Here comes a very important part. Now we are having dx to by x to the power of n plus 1, right? Should I directly write it as dt? Guys, never do that mistake. We know that your dt is nothing but minus n divided by x to the power of n plus 1 into dx. But here, I am only having dx divided by x to the power of n plus 1. But where is minus n? I am not at all having minus in the numerator. That means I am not at all having a right to write it as dt. If I am having minus n, then by closing my eyes itself, I would write it as dt. But here, I am not at all having minus n. Then of course, it shows that I should do something to make it as minus n. So as I'm not having minus n, I can't directly write this dt. But anyway, I should write this expression in forms of dt, right? Because then only my integral will become easier and my job will become easier, and I will get 4 marks. So what you need to do, well, listen carefully. Minus n to the x to the power of n plus 1 dx only dt. Here we are only having dx to the x to the power of n plus 1. We are not having minus n means, but somehow I need to convert this expression to dt. So what should I do is, I need to divide dt by minus n. That's the best method which you guys can do. dt by minus n will be dx to the x to the power of n plus 1. Correct now? dt by minus n will be dx to the x to the power of n plus 1, because dt is this value, divided by minus n means this minus n will cancel, so that you will be left out with dx to the x to the power of n plus 1. Now I am correct. If I divide dt by minus n, now I am getting this form of expression, which is dx divided by x to the power of n plus 1, and that is why I am saying divide dt by minus n, and then only you will get dx divided by x to the power of n plus 1. So when you divide dt by minus n, what you will get? dt divided by minus n into 1 plus 1 by x to the power of n. 1 plus 1 by x to the power of n is nothing but your t. Is nothing but your t. So I will write it as t itself. Okay, so 1 plus 1 by x to the power of n is nothing but your t, and that is something which I wrote now. So guys, I will repeat once again. In order to write this form of expression, which is dx to the x to the power of n plus 1 as dt, I divide the dt by minus n, so that you will be getting dx to the x to the power of n plus 1. I hope that makes you people clear. Now, when you divide dt by minus n, you will get dt divided by minus n, correct? Then 1 plus 1 by x to the power of n nothing but, now only I substituted the value. So 1 plus 1 by x to the power of n is nothing but a t, and that's why I wrote here t. That's all. So that's what I did now. Now guys, what we need to do is, we are having divided by minus n, right? I'm going to take this divided by minus n outside the integral. That means common. So when I take common, that means outside the integral, you will get it as minus of 1 by n. Because I am taking outside the integral, as we know it is in the division. Because as we know it is in the denominator as minus n into t, minus n into t. When I take that minus n outside, you will get minus of 1 by n. Guys, these things and all you guys should know. Because minus 1 by n, when you take inside, it will be minus of, d divided by minus n t. d divided by minus n t, when you take minus n outside, you will get minus of 1 by n. That's what I did. Now, this is the easy question. Because guys, what is dt by t? Integral of dt by t is nothing but ln of t. That's your formula of a indefinite integral, indefinite integration. So integration of dt by t is nothing but your ln of t. So I will write as ln of t, then plus some constant c, and this is the value of this integral, and I found using the substitution and some of the thinking. Do you know I am going to divide dt by minus n? That's your thinking. As soon as you see this, you should know that I should divide by minus n, and that is when I can write as dt. Those things you should be making a map on your mind, and that's when you will be becoming better. So I'm writing, so I wrote it as minus n divided by ln of t plus c, because minus 1 by n is correct. That I wrote. Now integral of dt by t is ln of t. That's your formula of indefinite integration. Integral of dt by t, ln of t, you guys learned in your indefinite integration formulas. Then plus some constant. ln of t plus some constant. That's all I did. Because integral of dt by t is ln of t plus some constant. That's what I did. Now, what is t? What I took as t? I took 1 plus 1 by x to the power of n as t. What is 1 plus 1 by x to the power of n? That is nothing but x to the power of n plus 1 divided by x to the power of n. Correct na guys? So plus some constant. Because minus 1 by n I wrote, then ln only, then I wrote value of t. Because don't think that if I substitute, I should not consider the t itself. That means I should not consider that 1 plus 1 by x to the power of n. That is, the substitution is to make your integral easier. It is not to erase off it. It is not to erase off it. That's why I am writing it as minus 1 by n into ln of t. What is your t? 1 plus 1 by x to the power of n. 1 plus 1 by x to the power of n, nothing but x to the power of n plus 1 divided by x to the power of n, just by taking LCM plus some constant. Now, this expression and the expression given in the question are same in sync. If they are same in sync, try to match them. We are having ln, same here we are having ln. We are having x to the power of n plus 1, here also we are having x to the power of n plus 1. Here we are having denominator x to the power of n, same here also x to the power of n. And constant also same. If they are same, then of course it shows that your a is minus 1 by n, and that's the answer for this question. So the value of a which arrived from this integral, which is minus n, because both are having a in it, and that's guys, so a is your minus n. So that's all about this question. Let us move on to our next question. Our next question is limit of n tends to infinity of 1 by n square plus 2 by n square plus 3 by n square, and it's going on to n by n square. So guys, we need to find the value of this limit. So guys, limit of n tends to infinity of, we know that n square, which is denominator, is common. That means it's same for every fraction, so that I can add the numerator directly, which will be nothing but 1 plus 2 plus 3 plus, and it's going on up to n divided by n square. Because guys, your denominator is common, because we are just having n square in it. So I will take my duster. So we are just having n square in it. Now this can be written as limit of n tends to infinity of 1 plus 2 plus 3 up to n number of elements, nothing but sum of first n natural numbers. Sum of first n natural numbers is n into n plus 1 divided by 2. That is the property, or you can say it is a formula you guys learned in your sequence and series, and that is something I am doing here. So guys, 1 plus 2 plus 3 up to n number of elements, nothing but sum of first n natural numbers, which is n into n plus 1 divided by 2. That's what I did. So n into n plus 1 divided by 2 I am having. It as it is divided by 2, I can take to the denominator, and that is what I did now. So this n and this n, I would cancel them. Now listen carefully guys. This can be written as limit of n tends to infinity. Limit of n tends to infinity of n plus 1 divided by 2n. Now I am going to take this 2 outside. In the denominator I am having 2, right? I am going to take the 2 outside. When I take the 2 outside, I will get it as 1 by 2 into this value. Why it is 1 by 2? Because guys, I am having that 2 in the denominator, and that is why it is 1 by 2. So what I did, just a basic thing, we know that we are having 2 in the denominator. I just took the 2 outside the expression. When I took the 2 outside, I will get it as 1 by 2 outside. Why? Because I am having it as a denominator. If I am having the denominator, that means that is 1 by 2. So 1 by 2, when I take it outside, what I will get? I will get n plus 1 divided by n. So this can be written as limit of n tends to infinity. N tends to infinity of 1 by 2 into n plus 1 divided by n is nothing but 1 plus 1 by n. Just the basic division using division of algebraic expression, splitting terms. By splitting up terms, which you guys learned in lower grades. So n by n is 1 by n is 1 by n. That's what I wrote. Now half into 1 plus 1 by n. So just evaluate now. Just put n as infinity. So 1 plus 1 by infinity. What is 1 by infinity? 1 by infinity nothing but 0. Because 1 divided by such a large number will be 0, right? Because 1 by infinity is nothing but 1 by such a large number. 1 by such a large number, somewhat it will be 0. Correct na? So this will be nothing but 0. So this 1 by n is 0. I will write as 0 itself. Now this will be nothing but half into 1. So half into 1 is nothing but half, and that's the answer for this question. And guys, it's an easy question. That's why I solved in a speedy manner, so that you guys would, because it's such an easy one. So what I did is just I used the sequence and series technique. Sum of first in natural numbers is 10 into n plus 1 by 2. Just I cancel out it. Then what I did, I took 1 by 2 outside. Then n plus 1 by n I divided using splitting up terms. Then you will get us 1 plus 1 by n. 1 by n when your n tends to infinity will be 0, because 1 divided by such a large number will be 0, and it will nothing but half into 1 plus 0 will be half into 1, and half is the answer. That's all about this question. And 1 by 2 is the answer, guys. So that's all about this question, and that's all about this question for today's session. So thank you. Make education simple.